This lesson we learn conductance, capacitive susceptance, and admittance. We're going to cover the terms and the definitions first. That includes conductance, capacitive susceptance, admittance. We have circuit, phasor diagram, formula, and at the end we have one example. Before learning the new terms, how about let's look at a note here. We have learned conductance already. The symbol for conductance is G. It is the reciprocal of resistance. Conductance is a measure of the ability of a material to conduct current. The unit is Siemens, or just S. Now let's look at the new terms. Susceptance. Susceptance is the reciprocal of reactance. So far we only learned capacitor. So the capacitive susceptance is the reciprocal of the capacitive reactance. The symbol we use to represent this is BC. And the BC, it is defined as 1 over XC, 1 over capacitive reactance. Same unit as conductance, because it is a type of conductance. The next term is admittance. Admittance is the reciprocal of impedance. So that is the ability for the entire impedance to conduct current. Not just a resistor, not just for a capacitor. So the letter that represents admittance is Y. Y, it is defined as 1 over impedance Z, is also a kind of conductance, so same unit, Siemens, S. The formula to find the total admittance, that is Y total, it is square root conductance square plus capacitive susceptance square. Here we have a circuit, resistor R and a capacitor C connecting parallel, connect parallel to the source voltage Vs. And here we have the phasor diagram. The horizontal arrow, that is the conductance, which is inverse of resistance. Resistance or conductance is always the horizontal arrow. This upward arrow, it is the capacitive susceptance. And then the sum of these two vectors, these two arrows, is the diagonal, this arrow. That is the admittance. Now let's work on one example. For this problem, we need to find the total admittance in the circuit below. After that, we need to convert this total admittance to the impedance. Given R equals to AT omega, we can find the conductance G, and G equals to 1 over R, and that is 1 over AT ohm. Using calculator, I get 12.5 millisiemens. Next, I can find the capacitive reactance. And that is XC equals to 1 over 2 pi FC. This equals to 2 pi. Frequency is 1 kilohertz from that voltage source. And then capacitance is 0.33 microfarad. And this is 1 over 2 pi 1 times 10 to the power 3 hertz, and 0.33 times 10 to the power negative 6 farad. Using calculator, I got 482.29 omega. Since we know the capacitive reactance now, we can find capacitive susceptance. And that is BC equals to 1 over XC equals to 1 over 482.29 omega. So BC equal to 0.07 millisiemens. Now we are ready to find the total admittance. So the total admittance is Y total equals to G square, the conductance square, plus the capacitive susceptance square, BC square. And plug in numbers. G is 12.5 millisiemens square plus BC 2.07 millisiemens square. Use calculator, I get 12.67 millisiemens. Now we find the total admittance. We are ready to find the impedance. Since total admittance equals to 1 over impedance, so this implies impedance is 1 over admittance. So since Z equals to 1 over Y, and we just calculate Y, that is 12.67 millisiemens, we can find the total impedance. Use calculator, I got 78.9 omega.